objects, designing everything that we use. Rotations are used all the time to make things look correct. Okay, so it says rotation 90 degrees counterclockwise about the origin. So we really want to do this point by point. So let's label the points here. We've got point I, J, and K, and H. I guess they're H, I, J. So we'll just label the ordered pairs here. So it's -3, 0, -2, 0, and then -3, -3, like that.
Mhm.
From the previous problem, we know that the transformation is -y, x.
Uh-huh.
Okay, so could you attempt to use that for the first ordered pair?
-3 and then 0.
Yes, that's the first ordered pair, but how do you transform it? Like, can you give me the new transformation of it? Like
Oh, 0, -3.
0, -3. Yeah, that's good. And sometimes it's useful to label that point and be like, all right, actually, let me choose a different. Well, I'll keep going in that color. All right, so the next one would be 0, -2. How about the last one? Could you change that for us?
-3, 3.
So the y value though is negated.
Mhm.
So see how it's already negative?
Yeah.
Becomes +3.
Mm.
Yeah, I don't really like this example, but it is what we've got here. So 0, -3, 0, -2, and then 3, -3. And so you have some sort of a triangle like this, and then you're supposed to label the new coordinates with primes. Did you see that in class?
Oh, yeah.
It's not like a big deal, but you need to differentiate between the original and the new, and prime is the way that has been chosen by math people.
Okay.
So again, I don't know if this visually, if this is clear, but it's you're rotating counterclockwise is this direction. So
Mhm.
you're rotating, you're kind of on that part of the rotation in the blue there. I don't know if
Yeah.
that kind of matches up with your eye or not.
Yeah, I get it. Mm.
Let me know when you get this down, and we'll go to number 4.
Okay.
All right, so number 4. So I guess I'll backtrack. I guess I would remember this formula for counterclockwise, and there's also one for clockwise. The rotations are the ones I would remember formulas for. The reflections, I think, are more intuitive because we actually see these in our daily life. Looking in the mirror, looking in the water, we see reflections.
Mhm.
So the x-axis here, that's critical that you use the correct axis here. So there's the x-axis. So you just choose each point like M, and you ask yourself, well, how far away is M from the x-axis? And it's 1 unit away. So you go the other direction 1 unit. Like when you look at yourself in the mirror, even though that's a virtual image, it appears to be however far away you are standing from the mirror,
Mhm.
inside the mirror. That's a virtual image. This is a real image, so we can actually draw it 1 unit away. You can think of like homes that are built. A lot of them look the same, just different ones. One's a reflection of the other, left versus right. So for n, same ideas. You just count the number of squares till you get to n. You can do a formula, but it's 1, 2, 3, 4, 5 squares. You go up 5 squares. 1, 2, 3, 4, 5. So that's n prime. That's m prime down there. And we do the same thing for the other points. There's L prime. You're just going down 2, so you go up 2. K prime is down 4, so you're gonna go up 4. 1, 2, 3, 4, like that. These are very natural to do, I think. You can tell me if you disagree, but
Yeah.
If you ever made like a snowflake as a kid by folding a piece of paper and cutting it out, and then you open it up, I mean, that's what we're doing here.
Mm-hmm. Okay.
Okay, can we go to 9 and 10 next before we go to the other ones?
Yeah.
They're more consistent with what we've been doing. All right, number 9. We're rotating again counterclockwise about the origin. So what I recommend here is to label the points. It's a good idea to do it in alphabetical order. G, H, I, J, G, H, I, J, like that. Could you give us the ordered pairs for each of these?
Yeah. G is -4, 3.
Good.
Mm,
You can give me J. J next if you want. The order doesn't matter. Just whatever you want.
-3, 2. Oh wait, no, that's H.
No, J is -3, 2. Yep, that's fine.
Oh yeah, right.
Yeah, the order doesn't matter here. Just getting them all down.
And H is -3, 5.
Good. And then the last one there, letter I.
2 or -2, 4.
-2, 4. Yeah, good. All right, so the counterclockwise 90 degrees is the following. It goes to -y, x. Now, a strategy that might help you to do these is to do them do them all the same. So do you see how the x value goes to the right to the y value? So like, why don't we just take that x value and put it in where the y value goes for all of them? That way we're doing the same thing over and over again that we know is right.
Okay.
For the first position now, you have to take whatever the y value is and then negate it. So like in G, the y value is 3, so you negate it and it becomes -3.
Mm-hmm.
What would go in this position here?
-5.
-5. Okay. And then you're looking at the 4. What would happen to the 4?
-4 and then -2.
Good. So the advantage of this approach is that you can do it very like if you like recipes, if you like to kind of follow the order, it's a lot of repetition. And then you just need to label the points here. And it's good to label them, each time with what they are. That's G prime. -4, -2. And sometimes it's hard to decide if it actually looks like it rotated counterclockwise.
Yeah.
We sort of want things to look a certain way. But this is correct. This is what is expected when this problem was assigned. This is the one what they wanted.
Yeah. Oops. Okay. This is actually pretty easy.
I like hearing that.
But I was looking at number 10 earlier and I got the paper. And yeah, it looks horrifying.
Yeah. Well, knowing the steps to take really helps. You know, I can't remember. Are you driving now?
Mm-hmm.
So the first time you drive, it's like, how do I get somewhere? And then you do it, you know, you go to school and you know how to get there, you go to a friend's house, and just seeing a few examples usually helps. And it's the same
Yeah.
rule. We just need to label the 4 points. I mean, this is my approach. You may see something's different in the classroom, but that's my approach. I like to label. I guess we need W first. Oh, V comes before. They chose some odd. Okay. W, X, Y, and Z. All right. V, W, X, and Y. We just need to label those points. So X I'll do first. It's -1, -2. Y is -3, -2. W is -5, 1. And V is -5, -4. So again, our the counterclockwise formula, there's a different one for clockwise, but there's for the counterclockwise formula, it's -y, X, and this is the one you want to remember.
Okay.
So will you come up with the new ordered pairs for us, please?
Yeah. Hold on, I'm not done writing this.
Yeah, take your time. This is the self-discovery phase of the lesson to see if you can do it on your own.
The first one's +4, -5.
Yeah.
Okay.
Good.
-1, -5.
Okay, I agree.
X is -1, 2.
That's the original. You just repeated this one.
Oh wait. X.
Yeah, so you've been doing them right. I don't know, something about this one didn't compute with you, but again, that X value goes into the, and then you negate the Y value.
Yeah.
And I heard something different. I think we'd have to play it back to know for sure, but nevertheless, here, keep going.
-2, -3, or no, +2,
Yeah,
-.
there you go. Good. All right, now when you graph it, I mean, you should have some idea, like one of the things you should see is like this line right here is gonna end up down down like here. Like that's one of those things you're like, okay, I think intuitively that should work. So we've got 4 - 5, that's your V prime. -1 - 5, that's your W prime. -2 - 1, and then -3, I'm sorry, 2 - 3, something like that. There's something not right about that. Maybe I didn't know 3 - 3 - 2. That's right.
Okay.
All right. So now we're going to move back to number 5. And these are These I think are the hardest because they're going backwards. You have to write a rule now for each transformation.
Mm-hmm.
And your options when you for what you do, the options are shift left right, shift up down, reflect, and there's two axes it could reflect over. It's the the x-axis or the y-axis. We've only done an x-axis one, but you could reflect over either axis. And then the rotations, there's actually a bunch of rotations. The ones we've been doing today are 90 degrees counterclockwise, but there are also 90 degrees clockwise. And then there's 180 degrees clockwise and counterclockwise. They're actually the same. So I'm not trying to overwhelm you. I'm just trying to let you know there's a bit more here. I don't know if it was covered in class, obviously, because I wasn't there, but maybe you know if it was there.
Yeah.
So like to me, this is not a shift left or and right or an up and down.
Ro-
It looks like some sort of rotation. And there's not a great way to do this. There's like writing the ordered pairs and then determining like which one it is based on the rule. So let me just jump down here. So let's write the ordered pairs of the original points. So W, for example, is 0, 3. And then W prime is -3, 0. And then what you're supposed to do here is like figure out, okay, how did it go from the original XY to the W prime? We'll notice that the X value is now in the Y position. And the Y value of 3 is just negated, but it's in the X position.
Mhm.
And that shouldn't surprise you because we've been doing a bunch of these rotation ones.
Yeah.
But then what we're hoping for is that the others are also the same. So like we've got to we can't just be like, oh yeah, it's that's it. Like I've got it. Like maybe not, depending on the instructor, that could really do some things that are pretty rough here. So this one's -2, -3. So the question is did XY, did it go to -y, x? So is the X value of U the Y value of U prime? And it is. Then did the Y value switch positions and just become negated? Yeah, it did. So we're looking pretty good. All right, so you're supposed to go through and do all the points. I mean, we're pretty solid at this point, but if we're on a tester quiz, we'd probably want to do this. So V prime is -4, -2. I didn't do this right. It's -2, -2, 4. So yeah, this one also checks out. It also goes from XY to the X is now in the Y position, and the Y value has been negated. So your rule for this one, a couple of things you could say. You could say it's 90 degrees CCW. That means counterclockwise. That's kind of a standard thing that is used. And then you can also add in the formula that we've been using.
Okay.
All right, for next one here, number 6, same thing. If you were going into a test or quiz, you would want to kind of take an educated guess about what you think is happening here. And to me, it looks again kind of like a rotation.
Yeah.
And we just confirm that with labeling the points. So K is -1, 4. And then K prime is -4, -1. And that checks out with our 90 degrees counterclockwise rotation. It goes to the X goes into the Y position, and then the X position is negative of the Y value. So this one's also a 90 degree counterclockwise. And we could show the rest of the work. I don't know if you need to, but I'll just keep going here. J is -4, -2. J prime is -2, -4. And again, that's consistent with the rule. And then our last point, L, -2, no. Yeah, -2, 0 goes to L prime, 0, -2. And that is also consistent with what we've been seeing. Hopefully the ones in the back are different. Nope. 8, I guess 8's different. 8's kind of interesting, but 7 is the same as 5 and 6.
Okay.
No variety, unfortunately. Okay, so I guess the rules for 7 and 8 are the same, right? The transformation. So we can just shortcut this a little bit by just writing the coordinates, and then writing the coordinates of L prime, M prime, and N prime, and then showing that they're all this rotation here. So like L is 1, 2. L prime is -2, 1. M is 3, 5. And then M prime is -5, 3. N is -1, 3. N prime is -3, -1. And these are all, again, xy to -y, x, like that.
Okay.
All right, number 8. So number 8 is more interesting because there's a couple of options. There's multiple ways to get from one place to the other. So for example, here, I know we've been doing a lot of rotations, but if you were to first reflect over the x-axis, this would have the following appearance. It would be I here, H up here, and J here. So it would look something like that. And that would be I prime, H prime, and J prime. Do you kind of see that visually? Sorry, my screen
Yeah.
lagging a little bit there, but that's not what's on the right here. Like on the right, it's not quite this, but we could then, and I'll show this a different color here. We could then reflect over the y-axis. So that J prime goes there, H prime is there, and then I prime is there, because you're getting the same distance from each of the points from the axis.
Mm-hmm.
So you might think, oh, well, this must be the rule. And it is. I mean, it's true. It does work. The problem is it's not the most compact rule. So these two together actually are a new rule, which is a rotation 180 degrees about the origin. Because when you reflect over each axis, you end up being in the diagonal position of where you started out.
Yeah.
and yeah, so they would want this one here. Now, there is a rule for this. We could probably figure it out by writing the coordinates. Let me think about this. Do I want you to? Yeah, let's do that. So let's write the coordinates of each, and then maybe you can come up with the rule. I mean, obviously you could just search the internet and get it, but there's some value in self-discovery here. So let's look at coordinate I, the original coordinate I. It's at a -3, -2, and then I prime is at 3, 2. What do you notice is the same or different about like the X value to the X value, the Y value to the Y value?
It goes from negative to positive.
Yes. So we might think the rule is keep the value, but just negate it. Let's see if that works for J. So J is -2, -5. J prime is 2, 5. Does that rule appear to be consistent? Does it work for this one? Excuse me.
Yeah.
Yeah, it does. And it also works for H. H is -3, -5. H prime becomes 3, 5, like that. So there's your rule, I guess, if you want it. It's more important to say it in words, to say that it's rotation 180 degrees about the origin. And it could be clockwise or counterclockwise, because you end up in the same position no matter which way you rotate. And if that's not clear, I can provide an example of that.
No, I got it.
Okay. Let me know when you get all this down.
Yeah, I got it.
Excellent. So we have some time left. We could go back over some stuff from the other day, or you could give me something new. We could log into your Delta Math, whatever you want to do. It's totally up to you.
I don't really have any other worksheets.
Okay. Do you have any Delta Math that you need to get done?
No.
So you're all caught up in class?
Yeah.
That's great. That's great. Has class been getting better for you in the past few weeks, or?
Yeah.
That's good to hear. How's your grade in the class?
Well, I have a D, but I turned in like a lot of my papers that we did.
Great. Is the goal to get it up to a C for the semester's end?
Yeah, a C or a B.
C or B? Okay. Do you know when your next test is?
I think our next test is the midterms.
Okay. And do you know if
Yeah.
it's going to cover everything that you guys have been working on, or just some of the stuff?
I think it's everything we worked on.
Okay. Is there any topics from there you'd like us to look at or talk about?
Yeah, there's this one. I don't know what it's called. It's on my computer.
All right, we've got some time here. If you want to just take a moment to look it up, just let me know when you've got some. I can also make you co-host if you want to share your screen at some point.
Okay. Um, I don't know. I can't find it, but
Can you, any recollection of the name, anything?
it was like it was word problems about like if someone were to move a ladder like 5 inches further from the building.
So
And
like, so okay, yeah, I think might have enough here to pull up some questions here.
we did something like it. I think it was the actual problems. I think it had the shapes and stuff, but they had word problems and I didn't understand the word problems.
Okay, yeah, let me pull up a few problems here and you can tell me if these kind of seem familiar to something you might have seen.
Yeah, they're on Delta Math.
Okay. Well, do you want us to log into Delta Math or do you want me just to give you some here?
Mm-hmm.
Let's just look at these. All right, so a tower casts a shadow that is 60 feet long when the angle of elevation of the sun is 65 degrees. So the picture here is there's a tower. It casts a shadow along the ground like this. And we want to find out something about this. Okay, so the shadow is along here. This is the tower. Which are they giving you? The height of the tower, the height of the shadow, something else?
The shadow.
Yeah, they're telling you the shadow is 60 degrees. Now, do you remember what the angle of elevation refers to?
No.
So it's like you're right here and you're looking up. When you look up, that's the angle of elevation right there.
Okay.
Because you can think of it as you're looking to the sky, you're looking up high. That's your orientation. So that angle measure right there is 65 degrees. Okay. And what do we want here? What are they asking for in this problem?
How tall the tower is.
Yeah, so let's call that H. Is that okay?
Mm-hmm.
Now this is the big jump for me is, do you remember, have you seen this before? So Katoa for sine, cosine, and tangent?
No.
You have not.
No.
Okay, so these are not representative of what you're doing then. Maybe you're doing, let me just look one more here. Okay, so here I found another question that could be useful.
Oh, converse of the Pythagorean theorem.
Yeah, and that's kind of what we're doing here. But is it to find an angle or a side?
That's all I got from
Okay.
it. Was I don't know. It was just word problems.
Yeah. So I think what it is like, let's just say we wanted to find the length of this rope right here.
Mm-hmm.
This is using the Pythagorean theorem. So do you remember the Pythagorean theorem?
So a squared plus b squared equals c squared.
Yes, but let's remember what it actually refers to. It's a right triangle, first of all.
Mm-hmm.
The legs are A and B, and the hypotenuse is always C.
Mm-hmm.
So in your picture over here to the right is 400 and 850. Which of the three letters are those two values?
A and b.
A and B, very good. So it's like this: 400 squared plus 850 squared equals C squared. Do you have a calculator handy?
No.
Any chance you can grab one?
Yeah. Okay.
So I want you to calculate the 400 squared plus the 850 squared, please.
It's 160,000.
So it's quite large but go ahead and add them together.
Okay. And it was 800.
So yeah, so are you squaring both of them, or are you doing them separately?
I'm doing them like separately.
Okay. So if you've got like a TI, something there, you can actually do it all together. Saves you from having to enter the information again, because you do need to add them together ultimately.
Is it 882 500,000, something like that?
Yeah, let me get you the full number here. So yeah, it's 882,500
Yeah.
equals c squared, but that is not the answer. You have to undo the square. How do you undo a square? Do you recall that?
You divide.
Use a square root.
Oh yeah, square root.
Square. So you have to take the square root of that number that you just found. And let's have you round to the nearest whole number.
Um, 95.
I think you mistyped this number. 882,500.
Um, 939.4147.
Just to the nearest ones place. Nearest whole number. So like 930, 39, something like that. Okay, let's try another problem here. The numbers got a little large on that one. That wasn't the intention. I just grabbed one here, but I think this will be a little better. Okay, so here we go. It says the bottom of a ladder. You're asking about ladder problems. The bottom of a ladder must be placed 3 feet from a wall. So here's a wall. Here's the 3 feet. And there's the wall. And it says the ladder is 12 feet long. How far above the ground does the ladder touch the wall? So when you look at this problem here, what stands out to you as the 12? What can you tell me which dimension is 12 in this problem?
I don't know.
Well, are they giving, what are you trying to find? Let's do it the other way. What are you trying to find here? How far above the ground does the ladder touch the wall? Which side is that in the triangle?
Oh, it's on the right.
Yeah. So this is our variable. We can call this like H. So that means 12 has to be the other side here.
Yeah.
Okay, now to solve this problem, we're going to again use the Pythagorean theorem. A squared plus B squared equals C squared. Can you tell me which values you have, A, B, or C?
B and
what else? I'm sorry.
C.
C, yeah. Now, could 3 also be A?
Yeah.
It doesn't really matter. Yeah. So we're going to write it this way. We're going to write H squared plus 3 squared equals 12 squared. So 3 squared is 9, and 12 squared is 144. What do we do from here to solve the problem? Do you recall anything from class when you did this?
You subtracted that.
Very good. So you have h squared equals 135. How do you undo a square root? Squares with a square root. Gave it away. Could you calculate that for us, please?
Yeah.
And round to the nearest whole number.
12.
Yes, 12 feet. I don't know what it would have you round to in a real problem, but or another problem, but that's
It was always round to the 10th place.
okay. So what would that be to the 10th place on your calculator there?
11.7.
I see the 6-1.
Oh, 6-1.
So that means it stays the same.
Oh, okay.
It stays at 11.6 because the 1 means to round down. Okay, let's do one more ladder problem. This one won't take very long. It's kind of the backwards of the problem we just did. This will be our last problem. Some motivation here. Okay, so I want you to try to draw the picture for this one. All right, so does your picture look, there's two possibilities, I think, reasonably. It depends on which way you want to orient it. Which triangle did you draw? The one on the left or the right?
The right.
The right one, okay. So the 15-foot ladder goes here and the 12-foot wall goes there. And then you're trying to find X. Does that look like your picture? I'm rushing a little just to get through this problem, but it's okay if it doesn't.
Audio is cutting.
Okay, well, let me just finish this one up here. X squared
Okay.
plus 12 squared equals 15 squared. X squared plus 144 equals 225. You subtract 144 from both sides. X squared equals 81, square root of both sides, and X ends up equaling 9 feet. Okay, good job today. Getting through the full lesson. We're gonna meet again next Wednesday at this time. And if you need an extra lesson along the way, just let your mom know and I'll schedule that with her for you guys. Thank you so much for letting me help you today, and I hope you have a great rest of your day. I'll see you next time.
You too.
Bye now.